Okay, I'm now doing graphing inequalities. So I thought I would use these as my graphing inequalities. So what we have is, by shading unwanted regions of the graph, draw and label the region R, which satisfies the following three inequalities. It means I'm going to have to do another one where I show it a different way. So y is smaller than or equal to 2. So that means, I think that has to be a kind of that sort of thing. So that means this bit here is not part of the graph. So I've got rid of that. Okay. Now, x is less than 3. Let's try a different colour. So let's do this. We'll find a hard one in a minute. So that would be this one. So that is everything that is above it is not what we need. And then the last one is y is less than x plus 4. So we put a nod where x is 4, where plus 4 is. And then y equals x would be the one that goes through like this. So it would be all the way like this. So essentially you're doing y equals x and adding 4. So it's there. Now this one I have to be a bit more careful with. So it is going to be that y, oh, and that should have been intermittent. So let's just put a few intermittent bits in. Right, and now this one, I've got to make sure that y is less than x. So let's just pick a point. Let's pick 2, 0, 2. So at that point, x is, this side is 4, and this side is 2, and that is true. So that means that this bit is true. So that means if I put a point here, that point is minus 4, minus 4, 2, so that would be untrue. So this bit is not it. So in which case, the bit that we'd call R would be, I presume, this bit here. So this bit that goes between those bits. Anyway, that's one. Let's see if we can find something a little harder. Or maybe we'll do something, here we go. Should we literally go into the hard bits? Oh, there's 5 inequalities. I would do it, but I just can't fit it into my page, so I'm going to literally go for something else. Here we go, I can do that. The region R satisfies the following equations. So far we've got y equals x is this one. And y equals -2 is this one. And then we need y is less than 4 minus 2x. So I'm just going to reorganize that to y is less than minus 2x plus 4. And then I'm going to put that in, and then I'm going to discuss what you have to actually do. So 4 is where it's going through, and if we're going minus 2x, means we go down 2 and along 1, down 2 and along 1, down 2 and along 1. You get the idea. So that gives us this. Well done. Okay, now we have 3 different regions. So in the case y is greater than or equal to minus 2, which means that y is bigger than minus 2. Oh, so it's all of this area here. I think we know which one it's going to be, so that's all there. And then y is less than x. So in this case, that would be all the area that is, so if we made that, if we just took this point here, that would be 2, and the answer is 0. So that is everything that's south of here. Oh God, this is such a mess. I'm basically gonna just put in everything and then get rid of the bit that it is. And then y is less than minus 2x plus 4. So if we pick another point here, that would be minus 2x, which is what? Minus 2 plus 4 is 2, and that's 0. So that's 0 is, that's 2, and that is true. So it's all the side of this side. Anyway, which basically all comes down to the fact that the bit that is r is this bit in here, which I haven't done very well. And that, oh good lord, and that bit is r. So you have to draw in the lines and not draw them in the way I've just done it. And then you have to check using a point, and I can actually do this. So let's take a point in here. Let's take a nice point. Let's take 0 minus 1. And then you have to check that it fulfills all the brief. So if we'd say minus 1 is greater than minus 2, that checks. Okay. Now if we put this in, minus 1 is less than or equal to 0, that is also true. And now if we put in minus 1 is less than 4 minus whatever it is, 0. So that is also true. So this area here is correct for that. And that is how you do inequalities. If you have something else you want me to do let me know. But that's basically how that works.